Hello, everyone, and welcome to this another series of webinar here at Tagpros Education. I'm happy that you're here. I'm happy that you're still listening with us, and I'm happy that you want to learn more about educational technology. And of course, for today's session, I'll be demonstrating and I'll be discussing with you the importance of online simulation tools. Okay, and I'll be sharing with you later on the two major educational simulation tools that I use during lecture or during discussion with my students. So, if you want to learn more or if you want to know more how to teach coding, programming, or robotics to your students, you're in the right place. So I would highly recommend that you listen properly, and I would highly recommend that you have an extra gadget or an extra computer so that later on during demonstration, you will be able to follow the lesson or the topics that I will be discussing with you. All right. But of course, before we start our discussion for today or our demonstration, let me just introduce myself. I am Dominic Sales, and I've been teaching coding and robotics since 2012, and I'm also a freelance web developer, mobile developer, and I do teach also 3D design and 3D animation. And if you can still remember, I was also part of Philippine robotics team starting 2013 up to present. All right. So I know you are all excited, and I know you are all ready to listen and to learn new things here in TagPros. So let's begin. First, let's define what is simulation tool, right? When we say simulation tool or simulation software, it is actually based on the process of modeling a real phenomenon with a set of systematic formulas, which means to say it is a program that allows the user to observe an operation or perform a process through simulation without actually performing it physically, which means to say online simulation tool or simulation tool is somewhat a tool that will help a teacher, aid a teacher or a student to perform specific tasks. Okay? Specific tasks that you cannot do it physically because of pandemic. Nowadays, simulation tool is very important. But why should we use simulation software or simulation tool? Simulation software is used widely nowadays since the pandemic started last 2020 to perform or process an operation, or we use simulation tools to experience, okay, to experience how the actual action works or performs in real life. Okay, that is how simulation works, and that is why simulation tool is very important nowadays. All right. So let's talk about the advantages of using an online simulation tool, whether it's online or offline. Okay. So I listed here three major advantages of using a simulation tool. Okay. Simulation software is very important, as mentioned a while ago, because of these actions or advantages. Okay, so first, simulation software transform abstract concepts into interactive visual content. Okay, which means to say this simulation tool can make the life of your students easier. Okay, So making it easier for students to understand the performance and the process of whatever topic you're lecturing or whatever topic you're demonstrating to them. They can become somewhat familiar with the equipment and environment and practice necessary skills without risking accidents to themselves. For example, you are a professor, a doctor, and you are actually teaching medical terms or medical processes. So it's using simulation tool to perform these actions later on can help students to somewhat familiarize the different parts, to somewhat familiarize the environment or to practice necessary skills without accident, okay, without risking themselves to accidents, okay. And the second one is simulation tool can track student progress and provide standardized feedback. Okay, so simulation tools can track student progress and provide standardized feedback that can aid teacher in developing students' skills. They can also offer targeted skill development, which students can choose, okay, which skills to improve. For example, in my case, I'm teaching animation, 3D modeling, programming, coding, and robotics. So students can choose what specific skill he would like to develop, okay, and at the same time improve, okay, or receive specific training or resources. So that the teacher later on, if the teacher uses a simulation tool or an educational simulation tool, he can see the progress of his students, and he can provide training materials. Okay, so these training materials can be easily updated, okay, developed or modified. Okay, and of course, if you are the teacher and you want your students to develop their skills well, you need to provide feedback. Okay, that is one of the major importance of using simulation tool. You can actually see the performances of your students. You can actually see the progress. You can actually track the progress of your students because when we say simulation tool, you can actually see them performing the action without physically or without doing it physically. All right. So number three here we have cost effective in the long run. Simulation based technical training, for example, in my part as a computer teacher, it is very cost effective. For example, I'm teaching robotics, and my upcoming students, let's say, for example, I teach programming to grade 10, 11, and 12. So these incoming grade 10 students, they do not have robotic kit or they do not have robots at all. So it is cost effective because we do not we do not need to provide a robotics kit anymore because we have this simulation tool. Okay, we have this simulation tool that can perform operations and action the same with the actual robotic kit. Okay, later on, I'll be showing you an example of an educational simulation tool. All right. So, simulation tool can be also reusable, and it can also improve processes, and it can also be realistic at the same time since the tools and the materials that you use in the actual teaching or demonstration, they are also available in educational simulation tools. Okay, so these are just some of the three advantages of using online simulation tools. And the question here, since I want you to understand later on the importance of simulation tool in teaching our students or your students to better understand coding and robotics or coding and programming, the easiest and fun way is that can simulation tools improve programming skills? Well, basically, simulation tools have found numerous successes and advantages in education, not just during pandemic, but before pa. Okay, so being used for teaching, training, and testing applications. As computer technology continues to improve, always remember that simulation tools or simulations will become more immersive and will continue to transform applications in education. Okay, most especially nowadays, we are in pandemic. You can see and we can actually feel the impact of technology, okay, educational technology. So now I'm going to show with you guys the top two educational simulation tools I use in teaching programming, in teaching coding and robotics. And these tools will help you learn programming in a very fun and effective way. Number one in my list, I have here the VEX Code VR. And the second one is Tinkercad. I know you maybe have heard of VEX Code VR. Now I'll be showing you how to use VEX Code VR. But before that, let's first understand what is VEX Code VR. Okay, so when we say VEX Code VR, it is an easy to use platform that allows you to code a virtual robot using either block-based coding environment powered by Scratch blocks or a custom developed text-based Python interface. So if you have an idea of what is Scratch programming, so it's simply a drag and drop programming, and it's very easy to use because its GUI, its graphical user interface, is very friendly and very easy to use. So you simply select the component, for example, or select the action that you want your robot to perform, and you simply drag it and drop it in your working environment, and then there you go. You can see the robot perform the actual operation. Okay, to help you understand how does this VEX Code VR works, let me show you the environment of VEX Code VR. Okay, so you can see here, there's a file here. You can actually create a new block, a new project. You can load your device. You can open examples. Of course, you can save your progress and put it in your download it in your device. Are different tutorials available. Okay, so if you want to learn more later on, you can simply go to tutorials and choose these different tutorials here. And of course, there are different activities available online. So you just simply select the activities if you want to know more. Okay. And for us to be able to see the actual action of our programming later on, you or we need to start to press start because we want to make sure that we can see the actual movement of our robot later on. Okay, so this is the simulation software. Let's just stop it first. To do a simple programming using VEX Code VR, your program should always start with when started. Okay, when started. And for example, we want our robot. This is our tiny little robot here, but you can also change the view here. This is the top view, and this is the side view. And you can perform different actions like this. Okay, so now let's go back to how to program. Okay, so when started, always start your program with when started. Let's say, for example, we want our robot to drive forward for about 200 millimeters. You can also change the unit of measurement to inches. Maybe you want to like 10 inches only. Okay, which means to say, if we press the play button later on, our robot will start to move forward for about 10 inches. And then after that, you can also turn right for about 90 degrees. Okay, so after 10 seconds, your robot will stop and it will automatically turn right. And after that, maybe we can um, drive forward one more time, change the unit of measurement, and maybe we can put it 5 here. And let's stop the driving. Okay, so if we want to see the actual output of this program, we simply press the play button here. So let's press play button here and let's see what will happen to our robot. You can see that our robot is actually moving. So 10 seconds only, and then it will automatically turn right. Sorry, it's 10 inches only, not 10 seconds. My bad. Okay, so let's reload one more time. Let's see the top view. Let's play. That's 10, and then move right, and then drive forward. So this is how you use this type of online simulation tool, which is the vr.vex.com. So you can perform more movements here. For example, set driving to velocity, meaning to say you can increase the speed. So maybe we can like set drive velocity to, okay, we can put like around 100% because the normal speed is 50%. So when we reload and play, you can see that the movement of our robot is actually faster compared to the initial movement a while ago. Okay, so using this kind of simulation tool, it will help your students to understand more about programming, and it will help you to teach coding and robotics the easiest and fun way because your students can see the actual output. Okay, they can see the actual robot perform different movement or actions. Okay, so if your students cannot provide, if you cannot provide the actual robotic kit, then you may use this kind of online simulation tool or this type of educational simulation tool. 100%, it will help you teach coding and robotics the easiest way. And it will help you engage your students to learn more or to focus more on your subject area. All right. So if you want to learn more about VR or VEX Code VR, you simply go to their website, and you can also like practice your programming skills here. It's drag and drop programming, so it's very easy to understand because as you can see here, the terms commands used are actually English terms, so it's very easy to understand. So you can add comments, you can choose the different blocks you created. There are also variables here, operators, mathematical operators. You have here the sensing. So if you want to use the sensors of your robot, you can use the different sensing components here. Of course, we have the loops. We have also the magnet here because we have this kind of magnet here because there are some activities that will let you pick something, some objects. Okay, so it will let you pick an object and then drop it into a specific location. That's why you can see a magnet here. So you use the sensor magnet to pick those objects or components. Okay, and then you can also change the playground. So as you can see, as I mentioned a while ago, you have the number grid map. Okay, art canvas, this maze, wall maze, dynamic wall maze, this mover, and so on and so forth. So it's up for you later on to learn more about VEX Code VR. All right. So the next online simulation tool that I would like you to know or to share is the one that is my favorite. Uh, this is Tinkercad actually, and this is my favorite. All right. So this is Tinkercad, and it's very easy to use. So I use Tinkercad to teach circuits. I use Tinkercad to teach 3D design and 3D design, and I use Tinkercad for code blocks lessons. Okay, so Tinkercad is free. You can just create your own account in their website. So just type in your browser www.tinkercad.com and you may create your personal account. So basically, if you're done creating your actual personal account in Tinkercad, you can see this environment. Okay, so you can choose between 3D design, circuits, code blocks, and lessons. Of course, our goal today is I'm going to show you how to use Tinkercad to teach coding and robotics or coding or programming. Okay, so simply use circuits, select circuits, and then let's create new circuit. Okay, this is actually the environment of Tinkercad, and it's very easy to use and it's very easy to understand as long as you have a basic knowledge about programming, of course. Okay, so I use Tinkercad in teaching coding and robotics, in teaching Arduino. Okay, since our students, some of our students, they do not have actual Arduino kit, or some parts of their Arduino kit are not actually working well or missing. So I in replace of that missing part, I asked them to use Tinkercad, okay, circuits in Tinkercad, because well, it's still the same, all right? So you can see here we have different tools here. Okay, these are the basic components, and you can show all the components also here. All right. So there's a lot of components, but we're just going to use the basic components here. Okay. So yeah, so I basically we have here the Arduino Uno RT. It's a microcontroller board that can perform different operations or actions. This is the main what do you call it? This is the main microcontroller board that we use in teaching robotics in our school. All right. So once you have the Arduino Uno RT, okay, our task is to simply turn on and off an LED. So I'm going to show you how it's done. So of course we need a resistor, and also we need a breadboard later on, an LED and a breadboard. Okay. So let's just fix everything here, put them together. Okay, so I have here the resistor. We need this resistor for us to be able to control the flow of the voltage coming from our Arduino Uno R3. And we have here the LED. You can actually change the color of LED. If you want blue, orange, yellow, or green, it's up to you later on. So let's try to use a blue. And then we can rotate, change the orientation of our LED. Okay, so and then we can put it here. All right, and of course connect our cathode to our negative, and let's connect. If you're new with breadboard, I would highly recommend that you search in YouTube how to use a breadboard. Okay, because well, it's very easy to understand. All right, but yeah. Okay, we also need to connect our negative port here, put it in our GND, because when we say GND, this is the negative or ground. Okay, so if you're new to circuits, I would recommend you search the different components or different terms used in circuits, or in circuit design, or in robotics. Okay, so now our circuit is complete. We are now ready to code. But before that, let's try to start simulation and see what will happen to our LED. So you can see our blue LED is actually turning on, because there's an actual, or there is a default program already in Tinkercad, and we just need to like edit it, modify it the way we wanted. Okay, so stop simulation and let's try to open the code. Well, as you can see here, this is the standard, or this is the default program in the Tinkercad. Okay, so set built-in LED to high, wait 1 second, and then turn off and then turn on for 1 second. So I usually use text-based programming for my students because they are already high school students, and they can easily understand drag and drop programming. So I used text-based programming for them to be like challenged more. Okay, so I'll show you. This is the code. You saw a while ago that our LED is actually turning on and off. It's because there is a default program already, and this there are two parts of Arduino program. We have the void setup and void loop. Under void setup, this is where you put your all your initializations, your variables, something like that. Well, under void loop, this is where you put your main code. Okay, this is where you put the operations that you want your Arduino microcontroller board to perform later on. Okay, so we have here the pin mode 13 comma output 13 because we use the pin 13 here, as you can see. All right, output because it's an LED. So when you say LED, on and off light, so it's an output component. And if we're going to change 13 here, let's say for example 12, you want to make sure that your pin here should be 12 also. All right, so going back to code, so 12 now, and then under void loop, you want to make sure to change 13 to 12 also, 13 to 12. And let's try to edit the delay. Maybe we can make it more like 5,000, and this one should be like 500 milliseconds. So there are actually 1,000 milliseconds in 1 second. So 5,000 milliseconds, that is 5 seconds, and 500 milliseconds, that's 0.5 second. So now we are ready to start simulation and focus on our LED. You can see that our LED is on for about 5 seconds and off and then on again. Okay, 5,000 milliseconds and 500 milliseconds off and then on. So this is how you use this type of simulation tool, which is Tinkercad, and it's very easy to use. Okay, so you just need to keep on practicing to get to familiarized with the environment, the setup of the simulation tool. I would highly recommend that you start using VEX Code VR first because it's drag and drop and it's very friendly to use. And then once you familiarize with the environment of VEX Code VR, you can proceed with using this kind of simulation tool, which is the Tinkercad. So I use VEX Code VR for lower grades, and I use Tinkercad circuits for the higher grade levels, like grade 10, grade 11, and grade 12. Okay, so basically, these are the top two online simulation tools that I actually use in teaching coding and robotics. And I hope you learn something about online simulation tools. Okay, so well, basically, um, technology is fast progressing. Technology is still developing, and we cannot predict what's the next technology that will be developed later on. But we are very much sure that these applications later on can help us engage our students to perform better, to perform more, to improve their skills, to help them prepare for the actual environment or for the actual or physical um, test. Okay, so this is my topic for today. I hope somewhat you learned something from my topic, which is simulation tool. And if you have questions later on, feel free to type in our comment section, and I'll be willing to discuss. I'll be willing to answer all your questions later on. So thank you once again. Thank you for listening. Have a good day, everyone. Stay safe. Bye bye.